Hour, weekly interactive math reviews for Math 1314 and Math 1324, presented by Ms. Yvette Chuca, Mr. Ruben Carizales, and Mr. Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need to, and so others who may have missed out on today's events will be able to come back and watch it. So now at this time, please mute your mics for the best sound experience. Otherwise, the feedback could interfere with information we will be sharing today. We'll be sending the 1324 room link on the chat so that you can connect to your session if you're here for Math 1324. We're not doing sign-in sheets this semester. Instead, we are logging in students through MyScio. So during the presentations, Ms. Patricia will be reaching out to each of you for your EPCC ID number and instructor's name to make sure you all receive credit for being here today. So please respond so that she can sign you in. Without further ado, I'll pass it on to our presenters so that we may begin. Thank you.
Thank you. Hello, everyone. So we're in our 4th week of class, right? And so for 1314 today, we're going to be looking at concepts that are mainly for chapter, like for your exam 4. So this is going to prepare you for what you're about to see in exam 4. And we're going to talk about linear, nonlinear systems, but we're also going to talk about matrices. So we're not going to get through the whole entire presentation, but I always like to put all the slides here anyways. That way, if you would like a copy of the PowerPoint, when I send it to you, you'll get all the slides. So if you are interested in getting a copy of this, I will provide my email a little bit later, and you can send me an email and I'll send you the presentation. Okay, so a linear system is made up of more than one line. So it has more than one linear equation. And so you can see they'll be set up in this format here. Now a solution is an ordered pair that when you plug it in for the x and y, it's going to satisfy the equation. But in order for it to be a solution for the entire set or the entire system, the ordered pair has to satisfy both equations. And you'll see an example here in a second. So a system can be a linear system, which means that it's made up of just lines, or it could be a non-linear system, which means that there's going to be lines and there's going to be other functions, such as a parabola or a circle or anything else. Okay, well, a circle is not a function, but it could also appear in the system. And then there's different ways of solving a system. You can use substitution, elimination / addition, or graphing. And the solution that we're going to be interested in is going to be where the graphs intersect. Okay, so here's 3 examples. It says find the solution to each system below if it exists. So this first system here on the left side is a linear system because it's only made up of lines, okay? And the solution is going to be where the 2 lines intersect, and this point here, 2, 0, is where the lines intersect. In this second example, this is an example of a nonlinear system because it's made up of 1 line and a parabola. And here, the solution set is going to be this point here, 2, 1, and this point here, 0, -1, because that's where the graphs intersect each other. And then over here, we have a parabola and a line. And so the solution is going to be where the lines intersect. But if you notice here, these 2 graphs do not intersect. And so what we say is that there's no solution to this system. Okay, so we don't always have a graph though. So if we want to know if 0, -4 is a solution to this system, well, there's 2 ways you could do it. You could graph the lines and see if they intersect at this point, or we can do it algebraically and we can plug in the 0 for x and -4 for y in each of the equations. So here we get 2 times 0 minus -4 equals 4. And so we end up with 4 is equal to 4. So that's That's a true statement, so that we say that this ordered pair satisfies the first equation. But in order to satisfy the entire system, we have to check the second equation. So if I plug in 0 for x and -4 for y, I end up with -4 is equal to -9. And this is a false statement, so it does not satisfy this equation. Therefore, this point is not a solution to the system. So we can try letter B. If I plug in -1/2 for x and -5 for y, then I end up with -1 plus 5 is equal to 4. And 4 equal to 4 is a true statement, so that's good. And I also need to plug it into the second equation. So 8 times a -1/2 plus -5 is going to be -9 is equal to -9. So notice that in both situations, this ordered pair satisfies or gives me a true statement. So we say that this ordered pair is a solution to the system. So this ordered pair is a solution for the entire system. Now, if we want to find the solution, then we can try different methods. And the beauty of this is that the method that I prefer might be different than somebody else's method, but regardless of the method you use, you should end up with the same answer. Okay, so substitution method, we'll try one there first. So if you want to use the substitution method, the first thing you want to do is to choose an equation from these two right here, and we're going to solve for a variable. So I'm going to choose x plus y equals 4. If I want to solve for a variable, I'm going to subtract y on both sides, or I could have subtracted x. It doesn't matter which variable you solve for. Okay. Now step 2, the result that we get here in step 1, we're going to plug it into the second equation, or the equation that we haven't used. So we haven't used x minus y is equal to 2. So anywhere I see an x, I'm going to substitute 4 minus y. And then I get minus y is equal to 2. And I'm going to simplify this and solve for the variable. So I get 4 minus 2y is equal to 2. I'm going to subtract the 4. So -4 on both sides. -4 plus 2 is -2. And then divide by -2. So I end up with y is equal to 1. Now we need a back substitute so that we can find out what x is. So your result, y equals 1, you can plug it in to any of the two equations that you have here. It doesn't matter which one you choose. So I'm going to plug it into the first one, x plus y equals 4. So I have x plus y is 1 is equal to 4. Subtract the 1 on both sides. So we get x is equal to 3. So our solution for this system is 3, 1. When you're entering your answer in WebAssign, just be careful because sometimes the computer will already have your parentheses. And so if you put another parentheses, it's going to count it wrong. Okay, so just always check, do we need the parentheses or is there already a set of parentheses there? So this is one way to solve this problem. The second way is to solve using elimination addition method. So to do this, you get to choose a variable. So if you don't like the x's, you can pick the x's. If you don't like the y's, you can pick the y's. It doesn't matter which one you choose. In this example, I'm going to choose to eliminate the y's. And the reason is, notice that I have a positive y here and a negative y. And that's going to be very helpful. Okay. So here we go. So I'm going to write my two equations. And then I'm going to make sure that the coefficients in front of the y are the same. So here we have a 1 and here we have a -1. So they are the same. So that means that I can add the equations. So I'm going to have x plus x is 2x, y plus -y is 0, and 4 plus 2 is 6. So here we have eliminated the y's by adding the two equations. And so if I divide by 2, I get x is equal to 3. Now that I know x, I can back substitute. And again, you can choose any of the equations you want. So I'm going to choose the first one. So if x is 3, then I subtract 3 on both sides, and that gives me y is equal to 1. So my solution set is 3, 1, and notice it's the same. Okay, so these are two ways to do this. The third way is you could graph, but if you graph, it's not as accurate, depending, especially if you do it by hand, it might not be as accurate. Okay, so let's try an example here. So now it says use any method. Okay. So when I look at these equations, I could see that the first equation, I already solved for y. So that's going to set it up so that I can use the substitution method because the y is I already solved for one of the variables. Okay. Since I know that y is equal to 2x plus 3, I'm going to take that information and plug it in anywhere I see a y in the second equation. So here I'm going to plug in, I'm going to have x plus, let me go ahead and, I'm going to have x plus 2. Instead of y, I'm going to plug in 2x plus 3, and then I'm going to simplify. So I'm going to distribute the 2. 2 times 2 is 4x. 2 times 3 is 6. And then I'm going to gather my like terms. So 4x plus x is 5x. And I'm going to subtract this 6 to the right side. So I end up with negative 4 minus 6 is equal to negative 10. Divide by 5, and I get x equals negative 2. Now I need to know what y is, so I back substitute. And I'm going to do it on this side. So again, you can choose any equation. So 2 times negative 2 plus 3 is equal to y. So we end up with negative 4 plus 3 is negative 1 is equal to y. So always make sure that you write your solution as a solution set, meaning that you need the braces here, and then you need the parentheses here. Okay, so let's try this one. Here you can see that it's also set up for substitution. So let's go to the next one here. Solve the system using any method. Here, you don't have an equation that's already solved for a variable. So the best method to use is going to be the addition method. However, if you want to use substitution, you can use substitution. But you might end up with some fractions, and so that might be a little bit more work there. Okay. So let's choose a variable to eliminate, and we're going to cancel the x's. And so remember that in order to cancel the x's, the numbers in front, the coefficients, they must be opposites of each other. And so this one should be a positive 5, or this one should be a negative 2. So we're going to have to manipulate our equation so that they can look to have the opposite numbers. Okay, so I'm going to go ahead and multiply the equation by 5 all the way across the first equation. So I'm going to have 5 times 2x gives me a positive 10x. 5 times negative 7 gives me a negative 35y. And 5 times 3 is 15. Now, the reason I wanted to do that is, notice what's going to happen here. I'm going to have two equations, right? So on the second equation, I also going to multiply by a positive 2. So I'm going to have 2 times negative 5 is negative 10x. 2 times 3 is 6y. And 2 times 7 is 14. So notice the number in front of x is a negative 10, and the one over here is a positive 10, and that's what I wanted to have. So we're going to add both equations. So 10x minus 10x is 0, negative 35y plus 6y is negative 29y, and 15 plus 14 is 29. And so if we divide by negative 29, we get y equals negative 1. Just remember, when you're multiplying, you have to go across the entire equation. Now that I know y, I'm going to find x by back substituting. And I can choose any equation. So I'm going to have 2x minus 7y equals 3. So 2x minus 7, we just said that y is negative 1. So negative 7 times negative 1 is positive 7. Subtract negative 7, so I end up with negative 4. So we end up with x equals negative 2. And so this is going to be my solution set. Okay, so what about a word problem here? So it says the given amount of annual interest is earned from a total of 9,000 invested in 2 funds paying simple interest. Write and solve a system of equations to find the amount invested at each given rate. So they give you the annual interest is 380, and then you have the first rate of 2%, and the second rate is 6%. Okay, so we can set up a system. So we know we have two investments, so let's call them A and B. And we know that if we add the investments together, it's going to give us a total of $9,000. Okay, and now let's say that A, we're going to let it be the 2%, and B, we can let it be the 6%, or vice versa. So I can set up an equation. A plus B is 9,000. And then the interest that we get from these investments is 0.02. That's the in decimal form, plus 0.06b is equal to the annual interest of 380. So now I can use systems of equations to solve for A and solve for B. So if you don't like to work with the decimals, you can always get rid of them. So in this case, if I multiply by 100, 100 times 0.02 is 2, and 100 times 0.06 is 6b, and I have to multiply 100 times 380, 38,000. Okay, so I'm going to work with A plus B equals 9,000 and 2A plus 6B equals 38,000. So let me write those equations here. So we need to eliminate a variable. So we can multiply the first equation by a -2. And if we do that, we're going to end up with -2 times A is -2A, -2 times B is -2B, 9,000 times -2 is -18,000. Now I can add them, so -2A plus 2A is 0, -2B plus 6B is 4B, and -18,000 plus 38,000 is 20,000. Divide by 4, and we get 5,000. So if B is 5,000, then we need to find A. So together we said it was 9,000, so that means that A has to be 4,000. So that's how much money you're going to put in each of the accounts. So you're going to put 4,000 in the account A and 5,000 in account B. Okay, so now let's go to a nonlinear system. So as I mentioned before, the middle picture and the right side picture are nonlinear systems because they have a line and they have something else that's not a line, in this case a parabola. Okay, so here the first equation is a parabola and the second equation is a line. So we want to solve for the solutions here. So you can still use the same methods that we used before. So in this case, notice I have a negative y and I have a positive y. So if I add these together, they're going to cancel each other. So I'm going to go ahead and use elimination, and I'm going to add the equations together. So I'm going to have x squared plus 4x, and then negative y plus y is 0, and 0 plus 0 is 0. So now I'm left with this equation here. So I need to still solve for x. So notice it's quadratic because of the power of 2. So they both have an x in common, so I can factor out an x. And I end up with x times x is x squared, x times 4 is 4x. So I can set x is equal to 0 and x plus 4 is equal to 0. So if I solve for x, I get x is equal to -4. So I have one solution for x. I actually have two solutions, and one of them has x equals 0 and the other is x equals -4. Well, we need to find the y's that go with those x's. So we can just take one at a time. So let's look at x equals 0. So if I plug in 0 for x, I'm going to use the second equation. 4 times 0 plus y equals 0. 4 times 0 is 0, so we end up with y is equal to 0. And then the second one, when x is -4, if I plug in a -4 for x, I get 4 times -4 is -16 plus y equals 0. Solve for y. So I add 16 on both sides and I get y equals 16. So your points here is going to be when x is 0, we got a 0 for y. So that's my first point. When x is -4, we got a 16 for the y. So in WebAssign, sometimes it asks you to enter the smallest x value first. And so if they do that, then you want to put -4 and 16 on this side first, and then 0, 0 would be your second point. Okay, let's try this one. So here, this is also a line and a parabola. So I'm going to go ahead and do this. We can use the elimination method again. And so the first one, I need one to be positive. So if we multiply equation 1 by -1, we get -1 times x is negative x, -1 times -1 is positive y, and -1 times -5 is a positive 5. So we're going to use this equation here along with the second equation. So let's write them together. And I can add the two equations. X plus x squared is x plus x squared. The y's cancel or gives me 0. And -5 plus -6 is -11. This is quadratic again. And so since it's not equal to 0, I'm going to take the 11 to the left side by adding 11 on both sides. And then you can either try to factor or you can use the quadratic formula. So here, I'm going to use the quadratic formula. So remember, you have your b, in this case is 1. So we have -1, plus or minus the square root of b, in this case is 1, minus 4 times a is 1, the number in front of x squared, and then c is your 11 here. Okay, so if we simplify, we end up with -1 plus or minus the square root of 1 minus 44. 1 minus 44 is -33. Since you have a negative in the square root, that means that this is going to be an imaginary solution. So there's not going to be, it's not going to cross here. So we're going to have a no solution, and it's going to be an inconsistent system. Okay, so the word inconsistent means that there's no solution. It means that the graphs don't cross. And if you have a, well, so let's look at this one. So we have x squared plus y squared equals 25. Does anybody remember what type of graph this is? If you were to graph it on the computer, what would it look like? X squared plus y squared equals 25. And then the second one, we know that's a parabola, but this first one is actually going to be a circle. Okay, so let's go ahead and solve here. So we can use the elimination method. So I'm going to multiply the first equation by -3. So I have -3 times x squared is -3x squared. -3 times y squared is -3y squared. -3 times 25, -75. So if we put both equations together and we add them, the x squares are going to cancel. -3 plus -3y squared. There's no other y squared, so we just get -3y squared, and then -16y. So we're going to end up with -3y squared minus 16y equals -75. This is quadratic, so I need to set everything equal to 0. So I'm going to bring the 75 to the left side. And then at this point, you can either try to factor or you can use the quadratic formula, whichever method is better for you. So I have negative b, so we're going to have a negative, and then b is -16 plus or minus the square root of -b, -16 squared, minus 4 times a is -3, times c, which is 75. So if we simplify, -16 squared is 256 plus 900, and that gives us 1,156. If you take the square root of that number, you get 34. So far we have y is equal to 16 plus 34 divided by -6. So that's going to be 50 divided by -6 is equal to -25/3. And then the second solution is 16 minus 34 divided by 6. Remember, since you have a plus or minus here, that's where we're getting the two different answers from. So 16 minus 34 is -18 divided by -6 is +3. So y gives, we have two solutions for y. So now we're going to find the x's that go with each of the y's. So the first one, y equals 3. If I plug in the 3 here for my y, then I get x squared plus 9 is equal to 25. And then x squared is equal to 16 if you subtract 9 on both sides. Take the square root of on both sides. So we get x is equal to the square root of 16, which is plus or minus 4. So here, when y is 3, we're getting two solutions for x. So one is a +4 and a 3, and the other is a -4 and a 3. So we're still missing one y, right? So the last y here is y is equal to negative 25 thirds. If we plug it in for y, then we end up with 25 squared is 625, and 3 squared is 9. This was negative, but if you square the negative, it becomes positive. And so I'm going to subtract negative 625 divided by 9 plus 25. If I add these two, I can see that that's negative. And if I take the square root of a negative number, then that's going to be not a real solution. Okay. So your only solution is going to be these 2 points that we have up here. Okay, so let me go ahead and I'm going to skip this one. That way we can go on to the matrices. And again, if you want this PowerPoint, you'll be able to see step by step how this problem was worked out. Okay, so these are examples from 8.1. So I know that some of you are my students, for example, and you guys are taking my class, which is 10 weeks. So right now you're still finishing up with chapter 2. So throughout the semester, I am going to send you this recorded video, especially when you get to chapter 8.1, for example. That way you can have it again. And then for some of you, you are taking a 5-week class. So right now you're probably seeing this. So don't worry, we're going to send you the recorded videos. If you're in my class, I always put the recorded videos for you as well. And if you're not in my class, they'll put the link for the YouTube channel so that you can watch those videos as well. So for 8.1, what is a matrix? So a matrix is just a rectangular array of numbers, and it's made up of rows and columns. The columns are going down, and the rows are going across. Okay. Now, in each of those rows and columns, you find what we call an entry, or sometimes we call it an element. And if you look at this one here, A11, the 1, 1 tells you where it's located. So this is located in the first row, first column. Okay, this is located in the third row, second column, and so on. Now the size of the matrix is found by the number of rows and the number of columns that it has. So here we would say that the size of the matrix, or the order of the matrix, is the number of rows by the number of columns. Okay, so here you either see it as there's 3 ways to ask you for the size of a matrix. One, they could tell you what is the size of the matrix. They might ask you what is the order of the matrix, or they might say what is the dimension of the matrix. But all 3 mean the same thing, which is what is the size. Okay. So if we look at the first one, this is a special matrix because we say it's a square matrix. And here for this square matrix, it has 2 rows because we can go across 2 rows, and it has 2 columns. So this is a 2 by 2. So we never say it's a 2 times 2 matrix. The multiplication symbol here, we just say it's a 2 by 2. This one is called the row matrix. And as you can see here, it only has 1 row, but it has 2 columns. So this is 1 column, 2 columns. And then the column matrix has 1 column, and it has 2 rows. Okay. So the order here is the number of rows, which is 2, and the 1 column. And then the identity matrix, which is also a square matrix. The difference here is that this identity matrix is made up of all ones in this diagonal, and everywhere else you're going to see zeros. Okay, but the order is still 2 by 2. So it says determine the dimension of each matrix, so like a matching thing. So the first one, you only have 1 number. So how many rows do you have? Well, you only have 1 row. How many columns do you have? You only have 1 column. So my answer for that would be letter G. Okay. And then the letter B, you have this matrix. How many rows do you have? Well, we only have 1 row. And how many columns do we have? We have 1, 2, 3, 4 columns. So this is a 1 by 4, so that would be letter C. Okay, so I'll let you try letter D on your own here. So this letter C is 2 rows and 2 columns, so that would be a 2 by 2. And then letter C, I will let you try it. And when I click, you can see if you got the right answer. Okay. I guess I erased the slide that had the answer. But so the right answer for this is you have 1, 2, 3 rows, and then you have 1, 2 columns. So that would be letter D. Okay. All right. So in this chapter, they're going to ask you what an augmented matrix is. So an augmented matrix just comes from a linear system. So this is your linear system. And the augmented matrix is going to be made up of all coefficients and your constants. Okay, so the coefficients go on the left side, and then your constants go on the right side of this bar. Sometimes the bar is not there, but it's kind of like we put it here, but some books might not have it in there. So here the coefficient of x is 3, coefficient of y is 5, my constant is -9, my coefficient of x is 1, and my coefficient of y is 4, and then we have -10. If you're missing a y, then you would still use a 0 to represent that that value. Okay, so here's an example. Okay, write the augmented matrix for the system of linear equations. And so here we would look at this row, and the coefficient for x is 1, the coefficient for y is 3, the coefficient for w is -1, and then your constant 9. So that's going to make up your first row, and so on. Okay, so we have 1, 3, 0, -1. And notice that I have a 0 for z here, because if you look carefully, this has x, y, w, y, z. So that means that I'm missing a z up here. So I'm going to go ahead and put a 0 for z. And then the second equation has no x. So I put a 0, and then y is -1, z is 4, and then w is 2. My coefficient, my constant is -2. X is 1, there's no y, so I put 0. Z is -5, and then w is -6. My constant is 0. And then I have 2, 4, -3. There's no w, so that's 0. And then I have my 4. The dimension or the size is 4 rows and 1, 2, 3, 4, 5 columns. So this is a 4 by 5 matrix. Okay. So what if they give me the matrix and they want to know what the system is? So we would do it the same way. We know that these numbers came from the coefficients of the variables. So here we're going to have 6 is going to be for your x, 5 is going to be for your y, 2 is going to be for your 2, and then 3 we have 3x, -9 is -9y, and then we have 0. So you might be wondering, well, is it always x and y? If they don't specify the variables, yes, you can use x and y. But if they say to use a different variable like z and p, then you would use those variables. Okay, so here's another example. We have a 1, and then we have a 0 and a 4. So what do you think this is going to be representing here? So for the first row, it's going to be, let's see if you get it right. So we have a 1 for the x, and then there's no y, and then you have your 4. And then the second one, there's no y, no x, and then there y, and is equal to 3. So when we're doing some work, we always want to have our matrix look like this one, because if it looks like this one, then we can get our solution for x and our solution for y. Okay, so how can we use matrices to solve these linear systems? And you might be asking yourself, if you're not asking yourself this right now, it's okay, but chapter 7 and 8, you might be asking yourself, well, why can't I just use chapter 7 methods to solve my system? And sometimes the answer is, yeah, you can actually, but matrices are very useful if you have bigger systems, like if you have 4 equations and 4 variables, or excuse me, or if you have 10 equations and 10 variables and so on. Okay, so If you want to use matrices to solve a system, then there's three operations that we're going to use. One is interchange your two rows, so you just switch two rows. The second one is you can multiply any row by any non-zero constant. And then the third one is that you can add any of the two rows together. Okay, so let me walk you through some of those. But before we do that, let me tell you what our goal is. So our goal is going to be to have, you're going to be given a system like this, and then you're going to write it into augmented matrix, like this one here. And then you're going to use these row operations to get to a matrix that looks like this one here, where you have ones in the diagonal, zeros everywhere else. Why? Because from this matrix here, we can say that x is equal to 4 and y is equal to 3. Okay, so that's going to be what we call in a reduced echelon form. And the process for this is called Gauss-Jordan elimination. Okay, so let's see what these operations look like. So you have interchange the first and second row of the original matrix. So this is my original matrix, and they want us to switch the first row and second row. So if you notice here, my second row is now my first row, and my first row is now my second row. Okay, and so we just switch them. So that's how that operation works. The second operation is that we can multiply by this half to the first row. So it would be half times 2 is 1. Half times -4 is a -2. Half times 6 is a 3. And half times -2 is a -1. Now the way we write this is you have a half times the first row, and whatever answer you get, notice that we placed it back in the first row. Okay, so the arrow means to put back, and we're putting it back into the first row. Now the third one is that you can add any number. You can multiply a number to any row, and then you can add it to another row. So here what we're going to do is we're going to multiply -2 times the first row, and then we're going to add it to row 3. And whatever answer you get, we're going to put it back in row number 3. Okay, so for example here, so we're going to multiply -2, oops, times row 1, so right here. So we have -2 times 1 is a -2. And then we're going to add it to row 3. So -2 plus 2 is 0. So I put a 0 here. And then -2 times 2 is -4. Plus a 1 gives me a -3. And then -2 times -4 is +8. Plus a 5 gives me 13. And -2 times 3 is -6. Plus 2, or plus -2, is going to give us a -8. Okay. And so those are the operations. And so let's do an example. And you can also use your calculator to do these. And so if I have time, I'll show you how to use your calculator on this. Or you can also look at my video that I have on how to use your calculators. I have a video for that, so I'll try to get the link and put it in the chat. But use matrices to solve the system. So here, just to remind you what we're trying to do, we're trying to go from this augmented matrix to something that looks like this, okay? And before I go to this slide, you always want to start by making this position a 1. And whenever you make it a 1, you're going to use this number to make everything below it a 0. And then you're going to go to the next diagonal, make that a 1. And anything above it, you want to make it a 0. And anything below it, you want to make it a 0. Okay? So here in our equation, I can see I already have a 1. And my goal is to have a 1 up here. So the operation I can use is switch the rows, right? So I'm going to take row 1. The double arrow means to switch with row 2. So this row 2 is now going to be my row 1. And my row 1 is now going to be my row 2. Okay. So now I have a 1 here, so that makes me happy. Now I'm going to make the number below it a 0. Okay. So what we're going to do there is This one, we're going to multiply by the opposite of whatever you see here. So I see a positive 2. The opposite is a negative 2. So I'm going to multiply negative 2 times row 1. And then I'm going to add it to row 2. So I have a plus row 2. And whatever answer you get, you're going to put it back in row 2 because we want to change the 2 is the one that we want to change. So we're going to put our answer back in there. Okay. So we have negative 2 times 1 is negative 2 plus 2 gives me a 0. So that 0 goes here. And then we have negative 2 times negative 1 plus 4 gives me 6. So I put my 6 here. And then I have negative 2 times 5 is negative 10 plus 8 gives me a negative 2. So now I have my 1, I have my 0. So my next goal is to make this 6 a 1. Okay, so to make it a 1, we're going to multiply by its reciprocal. So the reciprocal of 6 is 1 6. So we're going to multiply 1 6 times row 2. And then we're going to put our answer in row 2 because that's the row we want to change. So we have 1 6 times 0, 1 6 times 6, and 1 6 times negative 2. So 1 6 times 0 is 0. 1 6 times 6 is 1. 1 6 times negative 2 is negative 1/3. So now I have my 1, so that makes me happy. Now I need to make the top number a 0. Well, notice they're already a negative and a positive. So all we have to do here is add the two equations. So I'm going to add row 2 plus row 1, and the answer, I want to change row 1. So we're going to have 0 plus 1 is 1. 1 plus negative 1 is 0. Negative 1/3 plus 5 is 14/3. And so now what I can do is say x is equal to 14/3 and y is equal to negative 1/3. Okay. And so that is using the row operations to find your solution. So we can try one more here. What time is it? 3:42. Okay. So here we don't have a 1 at all, so we need to make this first number a 1. So to make it a 1, you can multiply by its reciprocal, which is going to be negative 1/3 times the first row. Put your answer back in the first row. So negative 1/3 times negative 3 is 1. Negative 1/3 times 4 is negative 4/3. And negative 1/3 times 22 is negative 22/3. Now that I have a 1 here, I want the bottom number to be a 0. So you're going to multiply the 1 by its opposite, which is opposite of this, which is negative 6. And then you're going to add it to the 6 to make it a 0. And so everything I just said there can be represented with this statement, negative 6 times your first row plus your second row, and then you put your answer in your second row. So I'm not going to change row 1, so I can just write it out. And now let's work on changing row 2. So we have negative 6 times 1 plus 6 gives me 0. So I put my 0. And then negative 6 times negative 4/3 plus a negative 4. Well, negative 6 times negative 4/3 is positive 8 minus 4 is equal to 4. And then negative 6 times negative 22/3 plus negative 28. So negative 6 times negative 22/3, that's going to be a positive 44 plus a negative 28 is equal to 16. So now we have the 1, we have the 0. So now we need to make this for a 1. So I can make it a 1 if I multiply by 1/4. So 1/4 times row 2, put the answer back in row 2. So I'm not changing row 1, so I can just write it down. And now let's change row 2. So 1/4 times 0 is 0. 1/4 times 4 is 1. 1/4 times 16 is 4. So now I need to make this a 0. So remember, we multiply the 1 by the opposite of this. The opposite of negative 4/3 is positive 4/3. So we're going to multiply 4/3 times row 2, add it to row 1, and then we're going to put our answer back in row 1. So we don't want to change row 2, so I can just write down my row 2, and now we can do the work. Okay. So we have 4/3 times 0 is 0 plus 1 gives me 1. 4/3 times 1 is 4/3 plus a negative 4/3 is going to be a 0. And then the last one, 4/3 times 4 is 16/3 minus 22/3 is negative 6/3, which is a negative 2. So now we can see we have ones in the diagonal, 0 everywhere else. And so my answers are x equals negative 2 and y equals 4. Now I do want to say that you always want to work with this 1 first and then make everything below it a 0 and then make the next one first and then make everything a 0. Okay. All right. So let's go to the next one. So in 8.2, you have some operations. So two matrices are equal if they have the same size and the same corresponding entries. You can add matrices if they have the same size and corresponding matrices. A scalar multiplication means that you're going to take a number and multiply it times every element in the matrix, and then you can subtract if they have the same order as well. So for example, here I have a 3 times a. 3 is called the scalar, and all you're going to do is multiply 3 into every single number that you see in a. So we would have 3 times 3 times 2, 3 times 2, 3 times 4, 3 times negative 3, 3 times 0, 3 times negative 1, 3 times 2, 3 times 1, and 3 times 2. So the 3 is the scalar being multiplied to every number in the matrix. And so we end up with 6, 6, 12, negative 9, 0, negative 3, 6, 3, and 6. Okay. Now for negative b, we have negative b, that's the same as negative 1 times your matrix. So we're going to multiply everything inside by negative 1. Negative 1 times 2, negative 2. Negative 1 times 0, 0. Negative 1 times 0, 0. Negative 1 times 1, negative 1. Negative 1 times negative 4 is 4, and so on. Okay. So now if we want to do 3a minus b, well, 3a, we did it in part A, and we got this matrix, 6, 6, 12, negative 9, 0, negative 3, and then negative b was negative 2, 0, 0, and so on. So to add the matrices, notice they're the same size. So we would just add 6 plus negative 2 is 4, 6 plus 0 is 6, 12 plus 0 is 12, negative 9 plus negative 1 is negative 10, 0 plus 4 is 4, negative 3 plus negative 3 is negative 6, 6 plus 1, 7, 3 plus negative 3, 0, 6 plus negative 2 is 4. Okay. Now, one of the questions I get asked a lot is I'm trying to put my answer, but the matrix is not big enough. What do I do? So when you're doing these problems, you're going to see these green arrows here. And if you press the down arrow here, it's going to give you more columns, okay? If you press the one pointing up, it's going to subtract them, and vice versa. If you press these arrows, you can control the size of the matrix. So here it wants us to add a plus b. So the size of a plus b is 2 rows and 3 columns. So this is 2 by 3. For b, we have a 2 by 2. So can we add those two matrices? Well, we cannot, right? Because they don't have the same size. Okay, this is 2 by 3. This is 2 by 2. So we would enter the word impossible. Okay, so we look at this matrix, solve for x and y. We know these are the same matrices, or they're equal to each other. So notice here I have a negative 4 and I have a negative 4. So this x has to be a negative 3 so that they can be the same. And this y has to be 21 so that they can be the same. So our answers will be negative 3 and 21. But over here, we have x should be the same as 2x plus 5. So we can set up an equation, right? And then we have this third one here, 5y minus 4, should be equal to 16. So we can set up an equation, and then we could solve for x. So x is equal to -5. And then if we solve for y is equal to 4. So it says solve for x in the equation where x is equal to 2a plus 2b. So here I have a 2 times the a, this is a, and 2 times b. The orders are the same, so I can multiply. I can add them. So first we multiply 2 times -3 is -6. 2 times everything in here is going to give me this matrix. And 2 times everything in here is going to give me this matrix. Now I can add them. So -6 plus 6 is 0. 4 plus 4 is 8. 6 plus -10, -4. -4 plus 10, 6. 0 plus 0 is 0. 8 plus 6 is 14. Okay, so I'm going to skip this one. It's the same here. So let me go to the next one. Okay, so to multiply. So we're almost out of time, but I think I can cover this so that we can at least see one example. So here we have two matrices. If you want to multiply, this is the row, the order m by n. That's how the size of it. And this is the size of n by p. In order to be able to multiply, the number of columns in the first matrix has to be the same as the number of rows in the second matrix. The outside numbers here is going to tell you the size of the new matrix when you multiply. So for example, if I want to multiply these two, I have to check the size, the order. So this has 1 row and 2 columns. This has 2 rows and 1 column. So if you notice, the number of columns here is the same as the number of rows. So since these two inside numbers are the same, then yes, we can multiply. Now the result is going to be a 1 by 1. So we're just going to have a 1 by 1. So how are we going to multiply? Okay, so you're going to take the first number times the first number, which is 4 times 1. And then you're going to take the second number times the second number, which is 1 times 2. And when you add these together, that's going to be your answer for that position. So 4 plus 2 is going to be 6. Okay, let's try this one. So for letter B, you have 2 by 1, and then you have a 1 by 2. The inside numbers are the same, and your result should be a 2 by 2 size. Okay, so we're going to multiply 1 times 4. So you're multiplying every row by every column. So 1 times 4. And then we're going to multiply 1 times 1, which is right here. And then we're going to do 2 times 4 and 2 times 1. So if we multiply it out, then we end up with 4, 1, 8, and 2. So this is probably are going to be, well, we might be able to have time for 2 more. But here we have a squared is the same as a times a. So we're going a times itself. The orders are the same, 2 by 2, 2 by 2. So notice the inside numbers are the same. So my result is going to be a 2 by 2. So you're going to take the first row. So you're going to take the first row here, and you're going to take the first column. So you're going to have 3 times 3 and 1 times -1. If you add those, well, I guess we'll go on to the next place. But what I was going to say is if you add this, 3 times 3 is 9. 1 times -1 is -1. So 9 plus -1 is going to be 8. That's going to be your first number here. Okay, but then you go with the second position here. The first row with the second, so 3 times 1 and 1 times 2. Okay, there's no more columns, so we go on to the second row. And we do the same thing. So -1 times 3 and 2 times -1. And now we go on to the second column, -1 times 1 and 2 times 2. So if we simplify this, then we end up with 8, 5, -5, and 3. Okay. Here we cannot multiply these together, right? Because this has 2 by 2 and this is a 3 by 2. And notice that the number of columns here and the number of rows are not the same. So the inside numbers are not the same, so we would just write impossible. Okay, so I think that was it for the last part of this was going to be on inverses and determinants. So if you go through these slides, you can see that these are step by step, and that would help as well. So if you want the slides, let me put my email in the chat. Okay, let me go to, you can email me, I'll send you these over. If you're not in my class, I encourage you to go to the YouTube channel, and you can find the recorded sessions from spring, or you'll find the recorded session for today as well. And if you are in my class, then every week I always put in the video that you are looking at. So like this week, I gave you some examples of the Friday happy hour for chapter 2. And then next week I'll put them for chapter 3 and so on. Okay. So if you have any questions, we do have some excellent tutors here and that can help you as well. And if you haven't responded to Miss Patricia, go ahead and respond to her, because that's the only way that your instructors will be notified of your attendance in case you're using this for extra credit, or if you're using this for part of your grade. Okay. But thank you guys for being here today, and next week will be our last session for the summer, and we thank you for coming, and I'll pass it back over to somebody in our staff.
Thank you, Ms. Chico, for your presentation. We do want to remind you all about our previously recorded sessions, which are available on the YouTube playlist. This session will also be available on that playlist later today. Also linked is a short survey to help us improve our Tve sessions. Please take a few minutes to fill out that survey, and remember to send your student ID number to Ms. Patricia. We sent individual messages to everyone so that you can sign in through there. If you would like to download a copy of today's presentation, you may go up to the top right corner and click on the box going down with the little arrow. That will allow you to download this presentation. Before you all leave, I want to share the Tve sessions that we will have next Friday. So next Friday, we're just going to have the final review, the final exam review, for Math 1314 and Math 1324. That will be our last session for Happy Math Hour this semester. Thank you all for coming in today. We hope you all have a lovely weekend. And if anybody has any questions, feel free to use the chat box or your mic. We'll be more than happy to answer anything that you have. We hope to see everyone again next week for Happy Math Hour, and good luck.